So thank you for having me, and I'm here to talk about Agoric. Agoric was a company started in 2018 pursuing a vision of decentralized cooperation through smart contracts. And I'll talk a fair bit about some of that. The reason why I'm here at Zcon is because our very first investor, the seed that got us started, was Zcash. And so a lot of the inspiration came from Zuko looking at the various smart contract failures that showed up in 2017 and saying, hey, there's these people out here that have a different way of approaching security that could really solve some of this stuff. And so there's been a technology and vision where Agoric was founded by pioneers in the space of smart contracts that have been working in this area for a long time. I worked on the first production smart contract back in 1989, and we'll talk a little about that. So I'm going to give an overview and a little bit of an update. I will go through a fair bit of things and, of course, take questions. So this is kind of the table of contents and the TLDR of where of what Agoric is doing. It is a layer 1 proof of stake chain built on Cosmos SDK. I'll talk a little bit about all of those. And its primary goal, the primary thing we bring to the table is programmability, where we enable the millions of developers that program in JavaScript to be able to build smart contracts. So instead of it being the privilege of a few thousand developers, we want to open it up for the broad mainstream market of developers, and that's a lot of what the platform is about. And it addresses, security hazards and solidity and reentrancy issues and all those kinds of things. And then it's not just being able to program in JavaScript, but being able to program in a modern programming framework. DeFi Legos, pluggable components, the kind of thing that developers are now used to being able to program their fancy user interfaces and interactive systems in JavaScript. And I'll talk a little bit about that. And then finally, the first use case, the first application being built on this platform and stack is a stable token for the interchain ecosystem, and I'll introduce several of those things. Now, I'm going to unpack each of these because many of the items or many of the words I used may be not entirely familiar to the Zcash community, and so I will expand those because this is a large project. So first, it's built on Cosmos SDK. Now, Cosmos is a ecosystem that is where the Tendermint proof of stake system was built up, and it's really a battle-tested proof of stake set of blockchains. So there are multiple blockchains built on the Cosmos SDK using Tendermint and connected with Inter-Blockchain Communication Protocol, IBC. And so the vision of Cosmos is lots of loosely coupled, independent blockchains all cooperating together, sort of voluntarily participating in interchain exchange and interchain commerce. And so there are lots of Cosmos-based blockchains, Tendermint-based blockchains, of which 46 now are connected in this network with IBC, where messages and transactions can flow back and forth between these chains, and there are literally 200 in progress. Some of them will be coming online. Every month there are additional chains that are connecting up to this interconnected network of blockchains. And so, there's in the current market, the connected networks are around $10 billion in assets. There are much more than that in the not yet connected but soon to be connected networks that will tie into this overall interchain. And it's not just, I'll talk a little bit more about IBC. So IBC is what connects them. That's a big part of the vision. IBC can be viewed as TCP for blockchains, right? It is blockchain neutral, works on Cosmos, and that's where it was sort of inspired, but there are folks working on integrating it with Near, with Solana, with Polkadot. There are ways that, people have looked at how to integrate it with the EVM and so forth. And so it is designed for broad spectrum of usage using really the best practices for chain interop, right? So it's how do we do large scale distributed systems where a blockchain is just a computer made out of agreement rather than silicon, and how do we connect them reliably using the best practices people evolved for having chains talk to each other. And so it's all open source, it is permissionless, and it is extensible. In particular, you end up with a layer that bakes in these best practices for blockchains communicating with each other, and then there are application protocols on top of that. And so the token transfer application protocol was one of the first ones that was built up, but people have interchain accounts where one blockchain can act as a client and control accounts on another blockchain. So, a smart contract on Agoric or Juno or one of these things could create a trading position in Osmosis, an entirely different chain. There are people working on NFT transfers. There are Oracle standards. So definition of what, how should Oracle information, price information, rainfall measures, whatever, be communicated in a standard fashion among blockchains. Those kinds of things. And so. So it's really designed for broad adoption. One of the key ways, I talked about best practices. One of the key ways that IBC is different from a typical bridge is the bridges, the machines running to transport messages between two different blockchains are not trusted. Right? It is not that there is a multi-sig in the middle and participants on either side need to rely on the multi-sig. Instead, the blockchains on either end are verifying the light client of the chain at the other side. So, the Gaia hub is directly verifying that the Agoric chain issued a particular message to be interpreted by the hub. And that's a huge improvement in security and robustness and reduction in overall risk, because you don't have this additional narrow, centralized, controlled counterparty. So that's, the quick overview of IBC. Each of these things has more elements and depth to it, but as I said, we're covering a large territory, so I'll leave it at that. So now we'll talk about the, smart contracts in hardened JavaScript. The first thing is to get people on board with the same notion of what we mean by smart contract, and it's not autonomous program running in Solidity somewhere. That, it predates that by quite a bit. The general idea of smart contracts, as I said, 1989, predates blockchain, is software that is enforcing the terms of a contract-like arrangement between third parties, right? And so that means, Airbnb, Uber, Lyft, eBay, PayPal, Venmo, high-frequency trading, all of those things are rights transfer, property transfer, incremental payments, whatever it is, but the process of that is enforced by the execution of software. There's not a human in the middle. And that's what enables, that notion of smart contracts enables software to mediate cooperation among strangers that don't know each other and may never ever meet. Right? So that's been the driving vision. And so Bitcoin, for example, is a smart contract, right? It is software that enforces the terms of transfer between parties. So Zcash is a fancier smart contract that does that with shielded transactions. So it's enforcing the rules even though it's not revealing the information. Now what blockchain brings to this, because smart contracts were $1 trillion market cap before blockchain came along. What blockchain brings to this is high integrity, right? You've got multiple machines in multiple jurisdictions with multiple independent administrators all coming to consensus about what happened in these smart contracts, about what choices were made, or did Dean place a bid and then withdraw it in time, or did the auction close and Dean won the auction? And only one of those can happen. And so much of when you look at the mechanics of blockchain, it's arranging for that consensus to give you reliable choices about what happened in this computation and then the results of those computations, right? And by doing so, you're executing with a level of integrity that did not exist before blockchain, because no one human, organization, or government is able to corrupt the integrity of execution. And so then we can move to smart contracts that, instead of relying on eBay or StubHub or whoever it is to correctly execute the soft contract that they made with the independent third parties, instead the software will enforce those terms, and that enables various forms of disintermediation, finer grained cooperation, so we can enable more cooperation among more people using this software we're deploying. Okay, So I said it's a big system, so now that we've got where smart contracts are, I'll talk about where some of the stuff is. As I said, there's the Cosmos Tendermint underneath that provides this backbone. Agoric relies on that. That's built, maintained, and operated by other people, and it's battle tested to the tens of billions of dollars in multiple chains across the US, or I mean across the world, right? And for us, our staking token is BLD, the build staking token, of which ECC owns a lot, right? or Bootstrap rather. So above that, we build what's based on the architecture of secure operating systems. And this is where what's called object capability security and the design of secure systems based on design principles that have been evolved over literally decades. We have a secure distributed runtime for JavaScript, or rather the hardened JavaScript that does islands of simple synchronous transactional programming in a sea of asynchronous messaging and communication. So there's no reentrancy. Each contract is running independently and sending messages to other contracts inside of both the Agoric chain itself and also potentially across to individual machines, right? My phone or other blockchains or other Agoric systems, private chains, etc. So this is a architecture for how to do smart contracts embedded in the large-scale asynchronous world. And then on top of that, so that gave us JavaScript, right? That gave us the hardened JavaScript, which is JavaScript with a few of the that we've been driving in the JavaScript Standards Committee with some of the areas of mutability that are maybe okay on the web but not acceptable for smart contracts locked down, right? And that allows us to take arbitrary code from arbitrary third parties and run it inside a confined box and know that it can't get out and it can only do a certain limited number of things. That's sort of the critical design element that lets us build a smart contract infrastructure that people can implement smart contracts in JavaScript. But JavaScript was in browsers for many years, and people did, experts did kind of cool things in these browsers for applications. But then modern frameworks like React and Vue came out for building applications and doing user interfaces in JavaScript in the browser. And 6 months later, relative amateurs could do flashier, more interactive, more internationalizable, more robust, adaptive, responsive applications than experts could the year before, right? And that's because they had a framework in which they could take components, a slider, slideshow component, and a credit card processing component, and put them together to build a site that would sell their art, even though they never in their life could have built that slideshow component or knew how to integrate with it with credit cards. And that ability to have these components that plug together with affordances of, what happens when I click on refresh or change tabs or do some other navigation and then go back, and all those details are now absorbed in the framework where experts could plug together alternatives, better navigation, different navigation, infinite scroll, all these elements that we see in modern applications that lots and lots of programmers can use, even though they're relying on components that other people built that they themselves might not be able to. And so that framework ability, that design of components is what enabled that to take off such that there are now millions of developers building cool applications with these frameworks. So we do the same thing for smart contracts, the same kind of thing for smart contracts. But here the affordances are not mouse clicks and rendering. It's establishing whether you gave me the asset I was asking for and determining the price and doing escrow and all these kinds of things that you need for building interesting, rich network of smart contracts and of cooperating businesses. And so the idea is, again, it's not just JavaScript, which is hugely valuable because there's 13 million developers use it. It's not just using the most popular development environments and language and tools that people have across a broad range of development activities. It's being able to have a framework that supports what we need to be able to do here. Okay, and we have several talks and presentations, so I won't go too much farther into this framework, but that's sort of a critical element, is we're not just talking about the language, we're talking about the components architecture that lets us use components built by other people and in order to develop interesting new applications. Above that, we do what's called the interprotocol, which is our stable token. I'll talk a fair bit more about that. But that's using that framework and building some initial components to produce an environment with a stable token. And then finally, there will be user-defined contracts, user-defined applications, things that remote so they can do, transactions on other chains, integrations with Zcash, integrations with Ethereum, integrations with all the rest of the crypto ecosystem, new applications, etc. Okay, so where does that get us? What gets us is water. So I talked about components and DeFi Legos, right? Or DeFi Legos is sort of a nice way to think about components built for doing finance. Turns out there's a lot of sets of Legos, right? We have DeFi Legos, we have governance Legos, we have NFT Legos that allow hierarchical NFTs and things like that. So examples are the simplest one, fungible tokens, right? Straightforward. But the architecture is such that that's just a digital asset. If I have an escrow application, and escrow is, there's an escrow trade example that is, 23 lines of JavaScript that any beginner could understand. But it's about digital assets, right? Electronic assets. And so fungible tokens, non-fungible tokens, semi-fungible tokens, where you can have, if you're in the world of gaming, 500 swords that are all equivalent, and I can trade one for the other, but they're different from the magic axis, right? Or whatever it is. Turns out that's really valuable for structuring gaming systems. But that same model of semi-fungible assets works for, people look at using it for recycling credits where, 5 tons of plastic are all fungible with another 5 tons of plastic, but they're not fungible with, 2 tons of aluminum, right? And being able to have simple reusable abstractions that just work across gaming items or recycling credits, turns out to be really nice. Automated market makers, XYK curves, if you're familiar with those. Vaults, which we'll talk about. Pluggable governance, I want voting by a committee, but this other group can veto it after 2 weeks, and then it automatically goes into effect. Being able to have Legos that you can plug together to do whatever you'd like to be able to do is hugely valuable. Okay, so I'll talk about some of these some more, but each of these is created, and I like to always have some JavaScript, some example code in presentations, is created, each component, each DeFi Lego in this framework, like with a React component, right? It's a single JavaScript module, it exports a start function, it takes an object, which is its access into the underlying environment, and then, for example, here on line 19, it's creating a mint for NFTs. This happens to be in an NFT minting contract. That's what it takes to create a mint. Down here is where it's minting the NFTs that this particular application wanted to do. And I'm not going to dig into the details of this application, but you can kind of see that, it's in VS Code, it looks familiar. When you hover over things, you get the pop-up help, and all the kinds of stuff that modern developers expect in modern applications. And if we want to get modern mainstream developers to come over and build interesting crypto applications, interesting systems that can leverage, shielded applications that can, all these kinds of things, we got to give them the tools they're familiar with. That's what, fintech developers, when they go looking for a new project, if they can't develop in it, then they're going to go find something they can do. Okay, so let me talk about then the first application that we're doing, and this is when we went to design the Agoric system, right? We looked at, okay, we've got components, we've got the ability to build these applications and build a community of developers producing open source components that third parties can use and so forth. But they need a place, they need to be able to deploy this stuff, right? They need to be able to take these applications and deploy them somewhere. That's a new economy, right? We're really, all building towards a new decentralized economy where now mainstream developers can participate. And so we'll start to see more and more mainstream use cases and applications. And that's really, Agoric's goal overall is how do we get all this stuff out to the rest of the world? Okay, so commerce, economies, rapid small businesses interacting, they require having a stable token, right? You require, you can't have three businesses that you're going to compare between if one's in terms of apples and the other's in terms of oranges, right? Stable tokens, currencies are the grease that makes an economy work. And if you don't have that, it's just sand in the gears, right? And so when we see systems like Ethereum where the asset you are using to pay for gas, if you think of gas as like your rent or like postage, it's like you're paying for your rent or postage with Apple shares. You can do it. It clearly works. But, currency emerged 5,000 years ago. Economists, understand that actually helps commerce and makes things work faster. We can overcome it, but if we want to get mainstream applications, we want to make it easy for commerce to accelerate and grow, we need, the backbone of that is having a stable token so you can have, multiple things priced in the same terms. You can have, you can have long-lived contracts where the price of a subscription is the same next month as it is this month, all those kinds of things. And right now, in crypto, we don't see a lot of long-lived contracts that are anything other than speculative vehicles. And so if you want to be able to have mortgages and subscriptions and loan agreements and so forth that are typical of mainstream commerce applications and a big backbone of sort of the larger scale commerce and supply chains and so forth, you got to be able to do that. And that means that intrinsic to this economy is going to be at least one stable token, right? And so, IST or Interprotocol has a token, IST for Interstable Token, and it's all about being a token not just for the Agoric platform, but for the connected interchain. And so it is backed by assets from across the interchain, whether that's Atom, ideally Zec, it could be Solana, it could be Juno, it could be Osmo, any of these kinds of things. If they've got the right characteristics, in particular, we'll talk some about that, then being able to use them as collateral for a stable token is really valuable. Now, there's several things that gets you. And let me see if I've got other slides here. I'll come back to that. So this is comprised, the interprotocol is comprised of several contracts, right? This is, again, it's not just that there's one contract, there's a network of contracts that are all useful and interesting independently, and some of which have been reused by other people to, for example, build a lending library or what have you. But these are just some of them, and there's, three or four more smaller ones. So vaults are the core. This is the MakerDAO style vault. The key thing is, there are multiple ways to do a stable token against the rest of the system. The one that is shown itself, in battle testing in up markets and down markets to work well is the CDP model. And, my analogy of that is, when people get home loans, right? I've got a house that is, worth sometimes more, sometimes less, depending on the market. You get a line of credit or a loan against that, so you're borrowing dollars, USD. Banks actually mint new money in that case. They list a deficit, a debt, an asset, and then you produce money against that. And then if the value of the loan comes down, you need to pay it down, or the value of the house, the value of the collateral comes down, you need to pay off some of the debt in order for the loan to still be valid. And otherwise, it's much, much worse in the case of real estate to reclaim the house and liquidate it. But that model actually works, and it's worked for a very long time in a wide variety of markets. That model of over-collateralized loan for stable token is how much of USD was created. You get gold in a reserve and you're minting dollars against it. Same model. Here it's crypto assets, so I bring over assets via IBC, bring over $200 worth of Atom, mint $100 worth of IST, take that across the interchain to use in applications or DeFi or NFTs or games or what have you, and go about my business. If the value of the collateral falls, I need to top it up by adding more collateral, or the system, when it crosses a threshold, will automatically liquidate it in order to pay off the outstanding debt, and the currency remains solvent. That mechanism is the vault mechanism, and it has, parameters for what that threshold at which it has to liquidate, whether there's penalties, all those kinds of things. Now, what's critical in in a stable token in this kind of model is not whether the asset, the collateral underneath, is volatile or not. That's just a measure that will affect how much over collateralization is required. Do you need $200 worth of some token in order to mint $100 worth of IST, or do you only need 150? Right? What is critical is being able to liquidate it. What is critical is having it be a token that has a market, that has buyers, that has places it can sell, so that if the value falls, there are people that want it, right? You know, Zec has that characteristic, right? It's available and sellable and tradable in multiple venues. That turns out to be the most important property for something that you're going to use as collateral. Okay. So vaults is the core of it. That's where most IST is minted. A complementary smart contract is the parity stability module, and that's where you can bring in a high quality, or a what I refer to as a reference stable token like USDC, like USDT, that is directly backed by, you know, in this case, dollar-based assets. So that it tends to be very close to $1 because it's backed directly by dollars. And so being able to arbitrage against that helps maintain the IST at parity with $1. And it's not critical that it be dead on $1, but it really wants to be very close so that you have, you know, you're using these tokens because they are stable in value, because they're very low volatility. That's what let you use, you know, represent and describe values over time in the units of IST. And so that's that's one of the critical contracts. Now, what's interesting about this is that there are multiple contracts that can mint IST under for different reasons with a different backing. You know, in the overall architecture, it is critical that IST always be solvent, always be backed by some set of assets, but it may be backed in different ways. And to ensure that the risk is managed, each one of those has its own debt limits, right? You know, so you can only bring so much USDC in order to have, if USDC, you know, breaks for some reason, you know, IST can still recover and be robust against it. You can only bring for each of the collateral types based on their volatility, their ability to liquidate and so forth. The amount of IST that can be minted against, you know, some new collateral would be much, much less than what could be minted against something that is well established and easily tradable. I'll talk about one more here, right? The native AMM, one of the mechanics in this overall system is, again, we've got a bunch of smart contracts that all work with each other. And so when a liquidation has to happen, you know, because the collateral value fell past a threshold, and so the vault mechanism goes, oh, okay, you know, I just got a signal from the Oracle saying the price fell. I'm going to go ahead and liquidate this vault. It can proactively, asynchronously liquidate it on the local AMM, right? It doesn't have to set up an external auction and wait for bidders to come in and that sort of thing. On the local AMM, it can immediately liquidate it and then arbitrage from the Agoric platform over to other platforms via IBC. So, you know, Crescent, Osmosis, you know, any of the DEXs that are bridged across to other networks, etc. Arbitrage with them can balance any impact on the pool here because of liquidation with those other pools of liquidity. And so the effect is that as things are liquidated in a trickle out to the market, you're liquidating into the much larger market across the entire interchain, not just on the one on the Agoric platform. And so there's a bunch of elements like that tie together this fact that we're building not just in a single environment, but we're building in this interconnected world of chains, the future, you know, interchain that has, you know, all of, not just Agoric, not just Cosmos zones, but everything from ETH to Zec to Solana to et cetera. Right? Okay, so what's next? Where does this go and how is this related to Zcash? So, one of the key things that is coming out of the interchain ecosystem is it's really ahead of the rest of the market in some important ways with respect to interchain DeFi, with respect to having people being able to bring in new applications that are running independently on a chain and collaborating with other parties across other chains. And it's very much welcoming of and sort of the heart of the current growth in thinking about interoperability. And so since founding, since we started talking with Zuko about Zec and about Agoric and about the programmability that this brings, the idea of having Agoric's computational model be able to interact with shielded assets, eventually in the future be able to have some computation itself actually shielded, all of those are things that have been, on our future radar. Currently, what looks like the lowest hanging fruit, right? Zcash or Zec code is looking at moving so that it's on a proof of stake system using the same Cosmos SDK architecture that we're using. And then it'll be trivial to integrate Zec. It'll just be another asset that's available over IBC that could be brought over to Agoric. But the model that you would want there, and the model that we want to be designing for, is people with shielded pools, shielded assets. They can bring those out essentially pseudonymously, take them over to some DeFi, and work with that DeFi. The key there, though, is going to be being able to easily take that Zec and convert it into IST, in our case, into a stable token, because all the rest of this DeFi world, it's stable tokens that really have enabled that to happen, right? The DeFi summer was enabled because there were multiple stable tokens that you could start to do curves with, that you could start to have derivatives markets that resolved in terms of stable tokens and so forth. That's critical. And the lowest hanging fruit to get strong utility out of the assets that people have currently in Zec is getting it bridged in so you can use it as collateral for stable tokens. Now, additionally, this, once it's connected like that, that should drive additional interest for people that want to be able to have the privacy that we should all consider normal for their use of assets. And so at that point, Zcash can become a place that people hold their assets to bring out and use use in DeFi transactions, and then come back and have it return to their pool of shielded assets. And so there's a lot of people that are thinking about this. And so what we're looking forward to over the next year or so is exploring options for how to bridge from Zcash into Agoric specifically and the interchain more generally. So that's kind of what's next. Questions?
One question. The inner protocol will bring in assets from the IBC network.
Mm-hmm.
In order to collateralize and then mint IST. Where do you expect IST to be deployed? If you were to draw a distribution across, IST use on Agoric-based dApps versus any of the other ecosystems with
Right.
Cosmos.
That's great. So the question was, IST is designed to bring assets collateral over IBC from other chains. Where do we expect to see IST actually used, though? Once someone produces IST, what do they do with it? So initially, our mainnet 1 is launching the platform, and then in order to enable the community to launch IST. And after that, it'll be permission contract phase for a while until we get to the point of permissionless contracts out in 2023. And so initially, the appetite for IST is on the interchain. So Atom holders are really excited to be able to take it over to make pools on Osmosis, to be able to take it over to Juno or Evmos, to have it be a settling currency for applications that in Evmos, that's a Ethereum-based Cosmos chain. That's where they'll be bringing over contracts that already work in Ethereum. There are a couple of derivatives platforms that they know derivatives need to settle into a stable token, and they don't want to do a stable token. They want something that's usable across multiple applications. And so you'd be able to bring it over there to, whether it's Seri Networks or Injective or any of those, to be able to be the settlement currency. And so the expectation is that most IST demand in the first 6 months will be on chain, on other chains across the interchain until we get to the permissionless phase on Agoric. But those chains, they're already rolling with and very much need a stable token to be able to flourish.
How does it compare then to other stable tokens in the Cosmos ecosystem? Because they can easily be bridged
Yeah, yeah. So the question is, how does this compare to other stable tokens in the Cosmos ecosystem? So there were, of course, some notable stable tokens whose economic design was unsound, and whether they were algorithmic or merely had bad algorithms. We all saw the debacle in April, or April, May. But there are other stable tokens. I mean, people are looking at various ways to bridge or bring USDC into the picture. USDT, there's projects working on implementing something similar in CosmWasm. The big thing that IST brings is the extensibility of the platform, right? Already it's got three ways. These are all three ways that can mint IST remaining solvent, supporting different routes and reasons and basis for having IST in the system, backing for having IST in the system. There's no reason to believe we're done there, right? That there's now delta neutral stablecoins that are, it's a little hard to tell whether you'd call them algorithmic or asset-backed, but they actually look financially sound. They require a rich derivatives market, so it doesn't make any sense to try and build that now, but in the future, when, as these economies grow, suddenly those will be not just viable, but very capital efficient, right? And there's no reason to believe that it's going to stop there. Similarly, we know already of multiple mechanisms that third parties would be able to build and plug into this infrastructure to provide, new, faster, more efficient liquidation strategies or liquidation mechanisms that work better for certain kinds of market participants. Liquidation insurance, so I can have lower over collateralization for my vault, but I'm paying a fee for someone to, if my collateral drops suddenly, they will pay down my debt so I don't get liquidated. All of those are mechanisms that require, safe composition that the people want to rapidly build. And so being able to have DeFi Legos and pluggability in the economy itself is going to be a huge leverage point for the next generation of DeFi. And that's something that you just can't have, you don't get in these other platforms. So I think the comment was that you need a financial engineer to figure out what all the applications could be. Right now, things start out relatively simple, but the future there's a lot more that we'll be able to do. That's absolutely true. Part of what we want is we want to welcome lots and lots of financial experts that are currently in fintech, and they went and looked at Solidity and went, yeah, come back when you've got a real development environment, right? And so enabling those people to actually participate and bring their expertise. We're not the ones that are going to come up with all the ideas to do this. Our job is to enable other people to be able to do that quickly. So. Question in the back. Yes, good question. So the question was, is the stability target for IST parity with the US dollar or something else? So from the Agoric platform perspective, we just need it to be stable. We just need it to be low volatility so that you can have long-lived contracts. So, because on the Agoric platform, you pay gas fees with IST, right? Contracts need to have an account that they know will be able to cover their gas for the next, the next half a year or whatever it is. Then the particular mechanisms by which the volatility is reduced and the particular target, that's up to the community. The expectation right now, and the reason why it's targeted at the dollar, at parity with the dollar, is because they're good reference currencies, and because there's a lot of businesses and mainstream businesses, they're quite able to handle something that is priced in $1 and compare, do I do this on chain or off chain? I'm getting this APR over here and, and that APR over there. One's on the blockchain and one's at a brokerage. Being able to compare those is really, really valuable. And so people generally right now, the most convenient target for parity is the US dollar. Thank you.